Yes, Nana. Good morning, students. So we are moving on to question number 89. See there, read Amma. A body is projected vertically upward from the surface of the earth. Its velocity time graph is. Four options they have given. What is the velocity and time graph? Okay. Yes. So question is, body is projected vertically upward. Like this it is projected. From body projected vertically upward. So when you are projecting vertically upward, your velocity is this side and you should use some velocity for that body. Because acceleration due to gravity is downward, what happened to its velocity, Nana? As it is moving up, velocity should decrease from maximum value. Clear? Yes. It will decrease, it will become 0 here, velocity will become 0 here and then come back. While it is coming back, its velocity will increases. No, while it is coming back, its velocity will increases. But the difference here is, while going up, velocity is that side. While going down, velocity is direction is this side. So direction of velocity will change. Clear? Yes. So while going up, velocity is positive. While going down, while coming down, velocity is negative. Clear? Yes. I am drawing the velocity time graph. Here it is your velocity, here is your time graph. Clear? Yes. So from where we have to start? This is the origin. Oh, okay. Now, initially is your velocity 0. If you give 0 velocity for this body to project, it won't go up. So you should do some initial velocity to this. Okay. Let us imagine that we have given some initial velocity something to this. Okay, you have given. Now, as it is moving up, with the time passes, what happens to its velocity? Velocity decreases. Okay, velocity decreases. So decreasing, I have drawn like this. Why I have drawn straight line? Because G is equal to constant acceleration is acting down. That is the reason I have drawn a straight line. Otherwise, I will do different lines. Okay. Next, so here what happened? It has reached the maximum height, so velocity becomes 0. Then thereafter, velocity increases. Velocity increases means, shall I draw like this? No. If I draw like this, velocity increasing, but positive here. But here, because the particle is coming down, velocity is increasing, okay, but it is negative. Upside is positive, downside is negative. So negatively velocity has to increase like this. So graph should be like this. This is negative velocity, no? This positive velocity, this is negative velocity. Here in this part, the velocity is decreasing, whereas in this part, velocity is increasing. With the time passes, velocity is increasing. Yes. So graph should be like this, and it is important. You must remember this type of graphs are important. Clear? Yes. Going back to that question. Question, yeah. See here. Yes. Option 2 is right answer. This is the right answer. Got it? Okay. Option 2 is your right answer. Finished. This question is important. See here, this point particle is starting from 0. No, if you want to project vertically upward, you should give some velocity. So this is wrong. Now come to this 3. Yes, first part is correct. Whereas second part, this second part also represent velocity is still positive. No, while coming down, velocity should be negative. So graph should be downward here like this. Okay. And this is a parabolic. This indicates velocity is acceleration is not constant. So this is wrong. Now I am going to 90. Question number 90. Question number 90. What it is given? A rocket is launched upward from the earth is surface whose velocity time graph shown in figure. The maximum height attained by a rocket is. Okay, yeah. So velocity and time graph given. I enter data first. They have given velocity and time graph. Yes, what have drawn in previous example, that graph only exactly it is. Okay, I am entering this data. This is velocity they have given, and these velocities are 100 here, exactly here 100 something. And then it is coming down like this. Okay. This is how much? 1000 is. It is 1000. 1000 what? Unit what? Meter per second is. So velocity is in meter per second. Okay. Next here down, x-axis what given? Time. This this is a time axis in seconds. Okay, and here it is. Here it is 20 given seconds, 20 seconds, and here 120 seconds. B is 120 seconds given. Okay, sir. So this is the question, and here 140 also given. Okay, I take that also. 140 seconds also given, and this is time. Okay. Now what we want, Nana? So this remaining are the 40, 60, 80, 100, that is not required. Yeah. What we want? A rocket is launched upward from the Earth's surface, whose velocity time graph is shown. The maximum height attained by the rocket is, okay. What is the maximum height it can attain? It can reach. Maximum height reach means what we want? We want displacement. Here you want displacement. Maximum height reach. See here, body is projected like this. How much maximum height it can reach? This much maximum height it can reach. Okay? That is nothing but it is the displacement. Now under this graph, we want displacement. If you want velocity type graph, if you want displacement, what you will do? You will find area under this graph. Yes. So displacement will be equal to area under the graph. Area is, it is a triangle, half into base. Base how much dana? 120 into height. Height how much dana? 1000. Finished. Unit wise you see, this is second, this is meter per second. Second cancel it meter only. Yeah. So 2 ones are 60 lakh. Answer is 60,000 meters. Or this 1000 is kilo. 60 kilometers. Option, let us check. 60 kilometers. Yes, Avai, good. Here see, options are in kilometers. So answer 4 is right answer. Anna. 60 kilometers it can reach. Good, Avai. Clear? Understood? No? Now I am moving to question number 91. In the above question, in the same question, height covered by the racket before retardation. See this question. 91 see Anna. This is the, in this question, there are just what is the maximum height it can reach. Okay? Yes. Now, see question number 91. They are given in the above question. Observe he has given 20. Good. In the above question, height covered by the racket before retardation, they are asking, okay. Height covered by the racket before retardation. See, if you observe this graph carefully, this is 120 seconds. Here exactly 20 seconds. This is acceleration, positive slope. This is negative slope, this is retardation. This is acceleration, positive acceleration. This is retardation. Okay? Before retardation means up to here. How much it can cover? This area point. This area point. This area point. Here, there's how much? Half into base is 20 into height is 1000. 1000 means 10 kilometers. Option is 10 kilometer is right answer. Yes, 10 kilometer. Afzal, I think so you have given wrong answer. Check. Okay? Next. In the above question, in the same question, the mean velocity of a rocket during the time it took to attain the maximum height. See this question, what they are asking in this diagram, what they are asking, the mean velocity of rocket. Mean means average velocity of a rocket during time it took to attain the maximum height. Okay, so to attain this maximum height, what is the average velocity of a rocket? V average is nothing but average velocity is what? Average velocity is 50 meter per second. 50. Where it is? Question number what? Question number 92. In the above question, mean velocity of a rocket during the time it took to attain the maximum height is. This 1000, no? It is 1000, no? It is 1000. 500 it is. Yes. So average velocity formula what na? Average velocity formula what na? Initial velocity plus final velocity by 2. That's it. When you know time exactly. Yeah. So initial velocity is 0 na. Final velocity is given already 1000 meter per second by 2. 1000 by 2 is 500 meter per second. Yes. 500 meter per second is the right answer. Any doubt in this? Yes, yes, option 3 is the right answer. 500 meter per second. 500 meter per second is the right answer. Any doubt in this? I think you understand this point. Any doubt in that problem? 92. In the above question, mean velocity of a rocket during the time it took to attain the maximum height. Average velocity is the sum of the velocities by 2. Two velocities, initial velocity plus final velocity by 2. Initial velocity is 0 because it is starting from the 0. Final velocity is 1000 given. Good. No need. Okay, good. Next, question number 93, Nana. In the above question, retardation of the rocket. How much retardation will be there? 10 meter per second square, Nana. Because constant retardation, acceleration due to gravity is acting there. Correct. If you want to see here, I'll show you. I'll stop this. In this above question, retardation of the rocket. This retardation we want. This is the retardation. Slope you take. Slope is changing velocity by time. Acceleration you want. That is changing velocity by time. Final velocity is 0. Minus initial velocity is 1000. Divided by time is 20 to 120 is 100. This time 100. So minus 1000 divided by 100. 0, 0, 0, 0 cancel. Minus 10. Minus indicates it is retardation. Minus 10 meter per second square is the answer. Simply orally can give, but if it is not Earth, then this type of thing you should do. Like this you should do. Retardation is this slope only you should take. Acceleration is this slope you should take. See, acceleration also same only you get. Acceleration is changing velocity by time. Changing velocity. Final velocity from here. Final velocity is 1000. 1000 minus initial velocity is 0 upon time. This time is given. How much is 20? No? Yes, 20. Yeah. How much? What happened? Thousand by 20, 20 cancel, 2 ones are 2 5s are 50 meter per second square you are getting. But they are asking retardation, no? Retardation only let us take. That is 10 meter per second square is the right answer, fourth option. See here, next question, 94 question. This is also just now I have solved. In the above question, acceleration of a rocket is how much? Just now we got 50 meter per second square. This is 50 meter per second square. Just now I have calculated. Here it is. Here it is. Retardation is here. Acceleration is here. Both we have calculated just now. Okay. Next, question number 95, Nana. In the above question, rocket goes upward and comes down on the following parts respectively. Okay. So rocket is going upward and coming downward. On which path it is going up and coming down? Conceptual question. This is velocity given and this is time axis given. Okay. So I'll take that diagram exactly. O, A, B, C. This is O, this is A, this is B, this is C. Okay. What they are saying, racket is going up and coming down in that following path. Okay, where the racket is going up. Here see, as the racket is going up, racket is going up like this. Acceleration is positive. So going up means this. This is up. And thereafter, it reaches the maximum velocity there. Going up like this up to OA. Then thereafter, velocity is decreasing, but its direction has not changed. Velocity, this is positive, this is negative. Here only the direction of a rocket will change. Direction of a rocket will change at point B. I mean, what I am saying is, this is the ground, this is ground. Rocket is going like this from here. Okay? Due to acceleration of rocket, it is going up. Reaches the maximum velocity. Then thereafter, it stops burning the fuel and still it will go up due to its velocity. Like if you throw a ball, it will go up, no, like that. So still it will go up and reaches the velocity 0 here. Then thereafter it will come down. Means going up is from O, A, B. Yes. Total path O, A, B is the upward direction. Are you understanding? And B to C is the downward direction. OAB is upward direction, B to C is downward direction. You should understand this. Are you understanding what I am saying? First, see, rocket is there, downward. How it will go up? By emitting some gas, it will go up. Clear? Yes. It goes up, reaches its maximum velocity at point A. Then let us imagine that it has stopped burning the fuel, emitting that the gases is stopped. Then what happened? Because at that point when it has stopped that ejecting the gas, it has some velocity in it. Due to that velocity, it still goes up. And while during this path from that point A, acceleration due to gravity comes into action, it decreases its velocity. So at the point B, velocity becomes 0. Means from A, O to B, it is going up only. Then at B, due to the acceleration due to gravity, velocity is becoming 0, it will turn back and comes down. So that means upward journey is O to B, downward journey is B to C. Yeah. So in the above question, where is here? In the above question, rocket goes up and comes down on the following respectively. Goes up is OAB and comes down is BC. Yes, fourth option is right answer. This is the right answer. Fourth question is right answer. Yes, this is the right answer. Fourth option. Understood? No? Any doubt in this? Any doubt? Now I am moving on to next question. Option D here. Why? Next, question number 96. Read question number 96. For the motion of a particle, acceleration time graph is shown in figure. The velocity time curve for the duration of 0 to 4 seconds is. Okay, acceleration time graph given. I am drawing that acceleration time graph now. 0, 1, 2, 3. Here it is 0. 1, 2, 3. 3 only, no? 3. 1, 2, 3, 4. Yes. 1, 2, 3, 4 given. Now, here down also is there. -1, -2, -3. This is time and this is acceleration. This is acceleration. So the graph is 3 to 2, 3 here up to 2. Then thereafter 2 to 4, where 3 only. 2 to 4. Yeah. So this is the graph they have given. This is in meter per second square, and this is in time, seconds. What they are asking? They are asking velocity time graph. What is the velocity and time graph? They are asking. Okay, I draw velocity and time graph. Here, okay, and I'll mention these all values. 1, 2, 3. Here -1, -2, -3. Here 1, 2, 3, 4 seconds. So we want velocity and time graph now. From 0 to 4 seconds. 0 to 4 seconds. We want velocity time graph. Okay. Now see, first graph they have given this, and from this graph up to 4 seconds they are asking draw velocity and time graph. See, listen carefully. This type of question is also important. First, from 0 to 2 seconds, what happened? There is an acceleration. This dot, this line shows straight line parallel to time axis, means acceleration is constant. That means 0 to 2 seconds, acceleration is equal to 2 meter per second square. It is constant, and that too positive because it is in upward graph. Okay? Constant acceleration is there, that is 2 meter per second square. Next, from 2 to 4 seconds, 2 to 4 seconds, what happened? Acceleration became negative. Acceleration is minus how much? -3. This is -3 meter per second square. This is also 3, no? Yes. This is also 3 meter per second square. Here also -3 meter per second square. It is constant. Parallel means it is constant. Now from this data, we should draw velocity and time graph. Velocity and time graph. Okay? Yes. We know that velocity v is equal to u plus at. Yes or no? Yes. Let us imagine u is equal to 0. U is equal to 0. Then v will be equal to 0 plus a value for here. How much then? 3. Into seconds. How many seconds? It is 3 plus 3 in 2 seconds. 2 seconds. So velocity will become plus 6 meter per second. 2 within 2 seconds. Means let us imagine particle has started from here. Velocity of that particle should become 6. 3, 4, 5. Let us imagine here 6 here. Okay? So it has to become 6. Where? In 2 seconds. Okay? Yes. In 2 seconds, velocity should become 6 here. It should become. And what is the acceleration? Acceleration is constant. Acceleration is constant. So for a constant acceleration, what is the velocity time graph? It is a straight line passing through the origin. Yes. So draw a line passing through the origin. Why I am drawing like this? Because acceleration is constant. It is fixed value. So that's why it is a straight line. Okay, from this velocity time graph, if you want find acceleration, take the slope. Slope is y upon x. Y is 6 upon x is 2. 6 by 2 is 3. S plus 3. Yes, we got perfect. Okay, so first data whatever we have done, it is correct. Now let's do here. Again, velocity is equal to u plus at. Correct? Yes. Now still here also. Now here velocity should become negative. Sorry, what is that? Acceleration is becoming negative. Clear? Yes. So velocity is equal to, initially meter per second minus acceleration is minus 3 into 2 seconds. How many seconds? How many? What is the time? Duration 4 means 2 seconds. So 6 minus 6 is 0. Means velocity is becoming 0. Final velocity becoming 0 in a time of 2 seconds. Means up to 4 seconds. Okay. Up to 4 seconds, velocity should become 0 again. So graph is. If you want to take the slope of this also, this upon this is 6, this is 2. 6 by 2 is 3. Yes, we got it. Perfect. And this slope is negative. So minus 2. So answer should be this type of graph. C. First option only is there. Yes. Option 1 is right answer. This is right answer. This is right answer. Clear? I hope you are understanding what I am doing here. This is wrong, this is wrong, this is wrong. So this will be the right answer. Understood, Anna? Any doubt in this point? Any doubt in this point? Reading graph is very important point. Abhay is asking that, sir, constant acceleration means uniform velocity. Yes, uniform velocity. Uniform velocity graph only know this. Acceleration is constant. That means uniform constant acceleration. That means acceleration constant means velocity is changing in equal interval of time. Change in velocity is same in equal interval of time. That is the meaning of constant acceleration. Okay, so this is the graph. Now I am moving on to question number 97. Question number 97. A ball is dropped from a certain height on the surface of a glass. So let us imagine drop some body on the glass. What happened? It collides elastically and comes back to its initial position. In this process, if this process is repeated, then the velocity time graph is. So you imagine you are having one ball and you are dropping that ball onto the floor. What will happen? It will go and it will hit the floor and will bounce back. If you see exactly, if you release the ball from this height, it will go down and it will come back not to the same position, somewhat less position only. If the collision between the ball and the floor is elastic collision, if the collision is elastic collision, then ball definitely will reach to the same height. Ball definitely will reach to the same height. About this elastic collision, we will discuss in future chapter, that is the work, energy, power chapter. Then we will discuss Newton's laws. There we will discuss. So what happened here? Ball is dropped from certain height. This is the ground. This is the ball dropped. What is initial velocity of a ball? 0. Yes or no? Yes, sir. Now, because on this downward direction, acceleration due to gravity is acting. Yes or no? Yes, sir. So when acceleration due to gravity is acting downward in the same direction of motion of a ball, then what happens to this velocity? Velocity goes on increases. Clear? Yes. Velocity goes on increases. It will hit the ball, hit this ground with the maximum velocity it can have. Clear? Yes. Clear? Yes. It will hit the ground with the maximum velocity. Then what will happen? Again it will reach up. Again it will reaches up. Then from there, again it will fall down. Yes or no? Again same thing. Again it will reach up. Again it will fall down. So this way process is continuation, they are saying. Now for this what we have to do? We have to draw a velocity and time graph. Velocity and time graph we should draw. Clear? Okay na? Velocity time graph only, no? They are asking. Then velocity time graph is see here, na? Initially, when the body is here, what is its velocity? Zero. As constant acceleration is acting, let us imagine maximum velocity body can attain while hitting the ground is V maximum. Let us imagine. Okay. Let us imagine it will take some time t to reach this ground. It will take some time t to reach the ground. Okay. Clear? Then how the graph looks like? Graph looks like this. No, yes. As the ball is dropping down, velocity increases, reaches the maximum. When it hits the ground, correct? Yes. When it hits the ground, reaches the maximum value. Good. Now, whether this line straight line or not, it is correct or not? How to confirm? Constant acceleration is active. So constant acceleration means graph should be like this. Yes, it is correct. Perfect. Now, once it reaches the maximum velocity, then what will happen, Nana? Then what will happen? Now, with that velocity, it is going up. With that velocity, it is going up. Now, first time is it is going down. Now it is going up like this. It is going up like this. Clear? Yes. Now, from this point, it is going up. Velocity becomes zero and reaches the maximum velocity like this. This point understood? What I have drawn? Up to here, okay? So velocity becomes maximum here, okay? So at this point, ball it is hitting maximum. Then what will happen? It will return. So velocity direction has changed. Velocity direction. Let us imagine downward direction is positive. Then upward direction negative. Upward direction. So when you hit the ground, velocity direction changes. Means negative imagine. Here it is positive, let us imagine. Downward motion is positive imagine. Then it will hit the ground and direction changes. Yes or no? Yes, direction changes, but it will still have the maximum velocity. So that's why its graph is starting from this. Now the ball is moving up. As the ball is moving up, what happens to its velocity? Goes on, decreases. Yes, see at a particular time, velocity becomes zero. Then thereafter, velocity becomes zero. Again, it is coming back like this same. So again, the graph should be like this. These two parts you must understand. Good. How are you saying, sir? Yes, sir. Good, understood. Good. So what I am saying, first the ball is coming down. This coming down, let us imagine negative. Coming down is, let us imagine positive. Yes, positive velocity. So when it will hit the ground, direction of velocity will change. It has to go up. Go up means velocity should decrease. And because it is negative, yes, velocity decreasing. Reaches the maximum height again. Second, this. Again, it has to fall down. Means again same like this graph. Again, after this, again the body will reaches here. Again, it goes in place. It is very important question given in JEE and NEET. Very important. Yes, this is the right answer. And they have mentioned here it is T and it is 2T. What is this? T indicates time of flight. Time to reach ground and time to reach up again. Time of flight. Again time of flight. Yes, it is very important question number. Detail to take the downward velocity positive, sir. So not understand. Bhai. Take downward direction is positive. This only. This is positive, no. While it is coming down, it is positive only, no. While going up, negative. That only I have explained here. While coming down, it is positive. I have explained. While going up, it is negative. See, perfectly. What I have explained, it is correct. Okay? I think so. You are not understanding. This is the right answer. Any doubt, Nana? Students, remaining students, any doubt? They are saying that downward is take positive. Yes, downward is have taken positive. Then upward should be negative. Upward is negative. Yes, see, upward is negative. Still any doubt? Okay, na? Clear? Got sir. Nishal understood. Yes, good. Still some questions are there. No doubt, sir. Good. Next, question number 98. A particle starts from rest and moves with a constant acceleration. Velocity and displacement curve is velocity and displacement. Particle is starting from rest. U is equal to 0 and moves with a constant acceleration. A is equal to constant. What they are asking? Velocity versus displacement they are asking. Okay. We know V square minus U square is equal to 2AS. This is 0. V square is equal to 2AS. A is constant. So that means V square is proportional to S. It is a parabola. Y is equal to X square. Graph. Parabolic graph. Correct. Option 2 is right answer. About this graph we have discussed initially before starting this syllabus. Next question number 99. Question number 99. The displacement time graph of a particle moving is shown. The instantaneous velocity of a particle is negative at that point. This is displacement time graph, Nana. Velocity can be given by slope. Okay. Slope is negative, then only velocity will be negative. Okay, slope will be negative at point E. See, at point C, positive slope. At point D, zero slope. At point F, positive slope. Whereas at point E, negative slope it is. So answer is 4E. Answer is 4E now. Because at E point, slope is negative. So that's why negative instantaneous speed is there at point E. Clear? Next, question number 100. Figure shows the velocity time graph of one-dimensional motion. Which of the following characteristic of particle is represented by the shaded area? So velocity time graph, shaded area if you take, what it will gives you? Area under velocity time graph gives us displacement. So option 2 is right answer, Nana. Displacement. Clear? Next. Time is not there, Nana. Time finished. So we will continue in next class. Okay, I hope you understand this class clearly, and some important questions also we have discussed in this class. Remember that points. Okay, yeah, bye.